Assalamualaikum warahmatullahi wabarakatuh. Innal hamdalillahi ala ni'matillah wassalatu wassalamu ala Rasulillah wa ala alihi wa ashabi mawala. Amma ba'd. Dear students, today we will learn about stoichiometry, and this is the contents. We will learn about mole, coefficient of reaction, empirical formula, limiting reactants, and also percent yield. First, we will learn about mole. To understand about mole, you have to understand this diagram because moles is the center of this diagram, which means moles can be converted to mass or to molar or to number of molecules. It means moles doesn't equal a number of molecule. Moles doesn't equal molecules. Uh, First, when we want to convert moles to mass, we have to multiply it by molecular weight or molar mass, and vice versa. When we want to convert mass to moles, we have to divide it by molecular weight or molar mass. And when we want to convert moles to molar, we have to divide it by the volume, and vice versa. When we want to convert it, when we want to convert molar to moles, we have to multiply it by the volume. And for converting moles to number of Avogadro, I'm sorry, number of molecules, we have to multiply it by Avogadro number, and when we want to convert a number of molecules to moles, we have to divide it by Avogadro's number. And the most important unit, I'm sorry, from the most important thing from this diagram is the units, because mole has many units. For example, we have mole, millimole, etc. And also for mass, we have some units: gram, milligram, kilogram, etc. And for molar mass, here we have usually we only have two. We can use gram per mole or milligram per millimole. And the last one, for the volume, we have liter, milliliter, etc. Why units are important for this diagram? Because when you use different unit, when you use different unit, it will result different unit. For example, when you use certain unit, it will produce certain unit also. For example, when you use mole, for moles, when you use mole unit and then you want to convert it to mass, it means you have to use molar mass with the same unit. You have to use gram per mole. You cannot use milligram per millimole because it will result different mass. Same here for the molar. Molar is a special unit. Molar is equal mole per liter or millimole per milliliter. When you want to convert molar to mole, you have to see the volume here. When the volume is in liter, it means you will get mole. But when you use milliliter, the volume is in milliliters, it means you will result millimole. This is very important for you, so please don't forget the units. And then uh, there is correlation between mole, Avogadro number, and also uh, the mass. This is, for example, a single molecule from water, one molecule water with the molar mass is 18, 18 atomic mass unit. It has 6.02 multiplied by 10 to 23 Avogadro number. This is when we have 1 mole. When we have 1 mole, it means it consists of 6.02 multiplied by 10 to 23 number of molecules. And then when we want to convert, when we want to weight it, 6.02 multiplied by 10 to 23 water molecule, it has 18 gram mass. This is the correlation. It means moles can be converted to mass and also be converted to number of molecule. This is just for an example. This is the relationships between mole and then molar mass and number of molecules. For example, for atomic nitrogen, we have the formula is N, and the formula weight is 14 with molar mass 14 gram per mole. It has 0. I'm sorry, 6.0 and 22 multiplied by 10 to 23 nitrogen atoms. It means 1 molecule of atoms, iron or molecules contains Avogadro number of those particles. And 1 mole of molecules or formula contains Avogadro's number times the number of the atoms or ions of each element in the compound. This is, for example, molecular nitrogen. It has N2 formula. It has N2 formula and with formula weight 28 with the molar mass 28 gram per mole. It has 2 multiplied by 6.022 multiplied by 10 to 23 atoms. This is atoms. Remember, molecule is different from atoms. This is for another example from barium chloride. Barium chloride has formula BaCl2 with the formula weight 208.2 and the molar mass is 208.2. It consists of I'm sorry, it consists of 6.022 multiplied by 10 to 23 BSL units or 6.022 multiplied by 1023 Ba2 plus ions and 2 multiplied by 6.022 multiplied by 10 to 23 chloride ions. This is the composition of barium chloride. Hopefully you understand it. And then we'll continue to law of conservation of mass. This is the basic of a chemical reaction from Antoine Lavoisier. Uh, why we have to understand the law of conservation of mass? Because chemical equation is based on that. Here, for example, uh, we have methane, and then we have oxygen. After we react methane and oxygen, we will get carbon dioxide and uh, water molecule. This is the projection from this reaction. We have methane CH4. This is the C atom, the black one, and the white one are the hydrogens. And we also have two O2 molecule. It means we have two molecule of oxygen consists of two atoms of oxygen. This is one oxygen, and this is one oxygen consists of two atoms of oxygens. And then we have carbon dioxide. It means this is the black one is carbon, and the red one are oxygens. This is the projection from this reaction. We have CO2 consists of one atom of carbon and two atoms of oxygen, and we also have two molecule of water. This is the oxygen, this is the oxygen, and this is the hydrogen. Now, the left side, the red one, we call it reactants, and the right side, we call it products. And in this parenthesis, states of the reactants and the product. G means gas, S means solid, L means liquid, and aqueous means aqueous. Uh, from this one, we will know that subscribes is not equal coefficient. It's not subscribe is different from coefficient. Subscribe is this, and this, and then coefficient is this. Nah, this is subscribe. Subscribe. So subscripts show us about the amount of atom. For example, this is H2O. It means we have two atoms of hydrogen and one atom of oxygen. And this is different when we have uh, this one, 2H2O. It means we have two molecules of H2O. This is because we only have, so this is we call coefficients, and this is we call subscribes. Okay, I'm sure you get it already. Coefficient show us the amount of the molecule, and the subscribes shows up about the amount of the atom. And then we will continue to molecular weight or molar mass. is the sum of atomic weights of the atoms in a molecule. For example, for ethane, from with C2 and H6, the molecular weight would be 2 multiplied by 12. 12 is the molar mass of carbon, and 6 multiplied by 1. 1 is molecular weight of hydrogen, and then we get 30 atomic mass unit. It means the ethene has um, 30 molecular weight or molar mass. Okay, then we will enter stoichiometry. Stoichiometry comes from word stoichion. This is a Greek language which means elements, and metron, which mean measurements. So the stoichiometry is an area of study that examines the quantity of substance consumed and produced in a chemical reaction. For example, ozone in the atmosphere, and then potential yield of gold from its ore, and assessing the processes for converting coal into gaseous fuels. This is the basic of a stoichiometric calculation. The main idea is uh, you use the mass or the molar mass or the mole from certain substance to calculate the mole or the molar mass, or I'm sorry, for to calculate the moles or the mass from another one. This is, for example, we have this reaction 2H2 plus O2, and then producing 2H2O. It means it has two molecules of hydrogen and then one molecule of oxygen, producing two molecules of H2O. In this reaction, for simply divide it, we can use the mass or maybe the moles of H to calculate the mole of oxygen, or to calculate the mole of H2O. Which the next step, we can use the mole to calculate the mass or maybe the molar from other molecule. This is for an example. We have 2H2 plus O2 producing 2H2O with the mass of hydrogens is 4 and the molar mass of oxygens are 32, and then we produce 36 of H2O. This is what we call law of conservation of mass. The weight or the mass from the reactants is always equal to the products. Okay, the different one is the mole. Okay. okay, but the mass is always equal. This is for the example for stoichiometric calculation. For example, we want to calculate how many or how the mass of carbon dioxide and water produced by combustion of C6H12 and O6. This is glucose, right? Now, there is no direct calculation from this uh, equation. It means when we want to burn 1 gram C6H12 and O6, first uh, we have to calculate the moles of the C6 H12 and O6. We divide it by the molar mass or the molecular weight. It has 180 gram per mole. When we have 1 gram, it means we have 5.556 multiplied by 10 to minus 3 mole of C6H12 and O6. And after we get the mole from this compound, and then we can calculate. Now, because this compound has only one coefficient, but the oxygen has six, and carbon dioxide has six coefficient, and also the H2O or the water compound has six. We have to multiply another compound with six, which means, for example, we want to calculate the amount of H2O, which means we have we have to multiply we have to multiply the mole of C6H12 and O6 with 6. Then we get 3.33 multiplied by 10 to minus 2 mole of H2O, and then we multiply it by the molar mass of water. The molar mass of water is 18, and then we get 0.6 gram of H2O. This is the step. We start with 1 gram of C6 and H12 and O6, and then we calculate the moles of C6, H12, and O6, and then we use the coefficient from each compound to find the moles of each compound. For example, this is uh, we want to calculate H2O, H2O, and then we turn the moles of water to grams. This is a simple step from stoichiometric calculation. And then after we understand about stoichiometric calculation, we have to understand about what we call limiting reactants, because not all reaction always has uh, the equal amount. This is, for example, uh, we have 10 molecule of H2 and 7 molecule of O2. After the reaction, we will produce 10 molecules of water and 2 molecules of oxygen. It means in this reaction, we have an excess reactance in this reaction because we have two molecules of oxygen remains, which means the limiting reactant is hydrogen and the excess reactant is oxygen. Why we should know this? Because it means when the limiting reactant is over, it means the reaction will be stopped. This is why we have to know about limiting reactants versus excess reactants, because the simply defined limiting reactant is the reactant present in the smallest stoichiometric amount. And the main the main point to calculate limiting reactant is this, the coefficient. You have to be aware the coefficient because the smallest usually not always the smallest coefficient. Limiting reactance is not always the the molecule or the reactant with the smallest coefficient. And then uh, uh, we will continue to the theoretical yield. Theoretical yield is the amount of product that can be made, or in other words, it's the amount of product possible as calculated through the stoichiometry problem. And the theoretical yield usually different from the actual yield. For example, this is from this reaction, we assume we will get 0.6 gram of H2O. This is what we call theoretical yield. For the actual yield, we have to burn 1 gram of C6H12 and O6, and then real the real amount of the H2O we get, that we call actual yield. And the after we get theoretical yield and the actual yield, we can calculate percent yield, which percent yield is an comparison between actual amount and the theoretical amount. The equation is percent yield equal actual yield divided by theoretical yield and multiply by 100%. And then this is for percent composition. This is the next metric for percent composition. Uh, for the equation from percent composition is percent element is the number of atom multiplied by atomic weight divided by molecular weight of the compound multiplied by 100%. So for an example, the percentage of carbon in ethane C2H6 percent carbon equal 2 because C has 2 subscript, and then multiply by 12. 12 is carbon atomic weight divided by 30. 30 is the molecular weight or molecular mass of ethane, 18, I'm sorry. And then we get the percentage of carbon is 80%. Uh, then, from the percentage of percent composition, we can predict the empirical formula. For example, the compound, we want to know the empirical formula of para-aminobenzoic acid, which is composed by carbon 61.31%, hydrogen 5.14%, nitrogen 10.21%, and oxygen 23.20 23.33%. And we are asked to find the empirical formula of PABA. This is the way. First, we know the mass elements in percent, and then we assume we have 100 grams of sample, and then using the percentage of each element, we calculate the mass of each element. For example, because we have 61.31% of carbon, which means from 100 grams of PABA, we have 61.31 gram carbon. Okay, I'm sure you get it. And then we have 5.14% multiplied by 10 gram, and then etc. And then we calculate the molar mass from each component to get the moles of each component. So after we get the mass uh, from each element, we use the molar mass from each component to get the moles of each component, and then we calculate the mole ratio. How do we calculate the mole ratio? To calculate the mole of ratio, we use the smallest mole as the divider. We use the mole, we use the smallest mole as the divider. And then we will get the empirical formula, from each component. This is, you can use this as an exercise. You will get a right answer when your answer is C7, H7, NO2. This is the empirical formula from PABA, para-aminobenzoic acid. This is the last one. This is an exercise. Please write it or do it on a paper, and then you can submit it on Google Classroom. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.